All right, so we're going to be going over some homework from section 2.2, numbers 59, 81, and 111. So to start, 59 says to determine the points, if any, at which the graph of the function has a horizontal tangent line. So a couple of things to consider here. First of all, it says determine the points, which means my final answer should be in an ordered pair because we're looking for a point. And then when I think about this, horizontal is going to mean a slope of 0, and a tangent line means the derivative. So I'm going to set my derivative equal to 0. So I'm going to start by finding my derivative. Y prime equals 4x cubed minus 4x, and then the derivative of 3 is going to be 0. I want to set that derivative equal to 0. So 0 is going to equal 4x cubed minus 4x. Go ahead and solve this. I can factor out a 4x, and I'm left with x squared minus 1. Still solving for x, this will factor into x plus 1, x minus 1, or you could solve it using square roots. So then I know from the zero product property that if I have three things multiplied together to be 0, one of them must be 0. So I'm going to set each piece equal to 0. So I'm going to get x equals 0, x equals -1, and x equals 1. So I found all of my x's, but if you remember, I was supposed to write everything as coordinate points on my original function. Well, the reason I say original function is that's going to be important because when I go to plug in my x, I want y to come back out. Well, here's y, so I'm going to plug my x's in here. So 0 to the 4th minus 2 times 0 plus 3, that's going to come back as 3. -1 to the 4th is +1, minus 2 times 1 is going to be -1 plus 3. I get an answer of 2. And then finally, 1 to the 4th minus 2 times 1 is again -1, and I come back with an answer of 2. It's really important that you go back to the original because we're looking for points x, comma, y. Also, some people tend to go back to here, but that's not y, that's y prime, and those numbers are then going to get you zeros because that's where the numbers came from. Okay, so be really careful that when it asks you to find a coordinate point, you go back to the original function because you're looking for a y value. All right, next thing, finding the equation of a tangent line. So finding the equation of a tangent line to the graph. Well, first of all, I know I want an equation of a tangent line, which means I'm going to need a point and a slope. I'm supposed to go through the point x naught, y naught, but that's not on my graph. I need to find the point of tangency, xy, using this equation that they give me. So I'm looking to find this point of tangency so that I can eventually write the equation of a tangent line. All right, well, it says to start by finding f prime of x. Well, here's f of x. F of x then is the same thing as x to the 1/2. I'm ready for calculus now, so f prime of x equals 1/2 x to the -1/2. Okay, so left side of my equation is going to be 1/2 x to the -1/2 equals, this part is x naught, y naught, right there. So my x value is -4, my y value is 0. And then this last part says that it's supposed to be the point xy. Well, in goes x, out comes y, the square root of x. So what I'm really trying to do is figure out where on my graph does this line that goes to the point -4, 0 connect at a point of tangency. So if you want a picture of this, I have the square root of x, I have the point -4, 0, and I am looking for my, put it in purple, looking for my mystery point. It's maybe going to be about there, such that this line is tangent. So what I know is that if I zoom in close enough here, my derivative in green is going to equal the slope of that tangent line. All right, so let's go ahead and do our algebra. So I'm going to rewrite this as 1 over 2 square root of x. equals, on the top I have negative square root of x, in the denominator I have negative 4 minus x. When you have two fractions that equal to each other, you can think about the concept of cross-multiplying. I don't love that phrase. I'm going to multiply this guy by negative 4 minus x. So that'll go away. Then I'm going to multiply this side by 2 square root of x, so that'll go away. So now I've got negative 4 minus x equals negative 2x. So, come on, computer. Negative 4 equals negative x, which means x is equal to 4. All right, but the final thing said that you're supposed to write the equation of the tangent line. Well, the equation of a tangent line, we said, needs a point and a slope. So I've got 2 points I could pick from. I could use the point that they gave me, negative 4, 0, because that's on this line, right? Negative 4, 0 is over here. Or I can use this new point that I just found, which was in goes 4, out comes 2. And then I need the derivative evaluated at that point. So my derivative was 1/2 x to the negative 1/2, which means I want 1/2 4 to the negative 1/2, which is really 1/2 times 1 over the square root of 4, which will leave me with 1/4. Okay, so thinking about the process, we wanted to find the value where our derivative was equal to our average rate of change. I'm actually going to change that phrase. It is the average rate of change, but it's more the slope between a point not on the tangent line and the point of tangency. Once I was able to figure out my x value, I could get my y value by plugging back into the original, and I could get my derivative or my slope value by plugging into f prime. Okay, last one to go over for section 2.2 is making a function differentiable. Well, in order for a function to be differentiable, it first must be continuous, right? Because differentiability implies that the function was continuous. But if a function is continuous, it's not necessarily differentiable. But continuity is going to be our first thing to check, so I'm going to check my pillars. Ax to the third is continuous everywhere, because it's a cubic function. X to the third plus b is continuous everywhere, because it's a quadratic. So the only place I might have a problem is at 2. So the first thing I'm going to do is find f of 2. And that's going to be a times 8, because 2 to the third is 8. All right. Next thing I got to do is check that my limit from the left so this will be ax cubed. I would like for that to be equal to my limit as x goes to 2 from the right of x squared plus b. All right, well, what value is going to make these things equal? On the left side, I'm going to plug in 2, I get 8a. On the right side, I plug in 2, I'm going to get 4 plus b. Well, now I'm stuck because I have 2 variables and only 1 equation. So if my function were to come back continuous, it would be because this relationship is true. So the next thing that I want to check is my function differentiable? Well, right now I have my functions glued together at x equals 2. I have 2 pieces glued together, but I don't know exactly what these pieces look like. I don't know if I'm coming together at a corner or a cusp or a vertical tangent. So what I want to make sure is that my slope from the left is matching my slope from the right, so that when I zoom in on this point, I have something that looks locally linear. Well, how do we find slope? Hopefully you're saying derivative. So I want to find f prime of 2 from the left, and I want to check to see is that equal to f prime, that should change to blue, of 2 from the right. Well, f prime of 2 from the left is going to be 3a 2 squared, because I can plug in 2. And I would really like for that to be equal to, the derivative on this side is going to be 2x, so 2 times 2. Well, on this side then I get 12a needs to be equal to 4, which means a should be equal to 1/3 in order for this mystery to be solved. Well, now if A is 1/3, over here, I can figure out what B is. So 8 times 1/3 equals 4 plus B. So this is going to be 8/3 minus 12/3 equals B. B will be equal to -4/3. Now just sit tight for a second. I'm going to show you something in Desmos. Give me a minute to pull it up. All right, so in Desmos, what I've pulled up is, I think you can see most of that, f of x equals ax to the third for x is less than or equal to 2. So that's my cubic function over here. And I put in one of those slider bars so I can make a anything I want to. And then I have x squared plus b for x is greater than 2. And again, I can slide and make b anything that I want to. So I'm trying to figure out how I can glue these things together. And right now, all I could find in that first part was that 4 plus b was equal to 8a, right? That's all I had, and that doesn't do anything for me because I have no numbers to make that a valid equation. Sorry, a valid relationship. So I did find, using the differentiability part, that a was going to be 1/3. And if a is 1/3, then that will make b be -4/3. And what I have created is a piecewise function that perfectly glues together at 2 with the same slope, locally linear. It's like the green and the purple are one line when you zoom in. All right, so hopefully that helps you with your concept of continuity first, right? Check your pillars over here, set that up, and then you want to set the derivatives to be equal because it's not enough to just glue them together. You also want to make sure that their slopes are the same at x equals 2.